Okay, so I wanted to make a video that was different from the practice so that you could still get bonus points from the practice, that I'm not just posting solutions, but still tried to capture a little bit of the patterns that start forming for this. So it's the same bridge. I've just moved the forces to two different locations. So let's figure out 9 kilonewtons applied at D and point K. And we'll keep the 3, 4, 5 triangle going on with this. Okay, step 1, solve for the reaction of the supports. We're looking at what's happening at A and what's happening at Z. To do that, we're going to take a moment, taking the moment around point A to add 0. So I'm going from A to Z. So this is going to be 12 times that length to FC. And this is going to be positive counterclockwise. So you're unscrewing it out of the board. It's coming towards you. And this yellow is fighting against the green. So we're going over 5 units to K. This is 5 times L times force. So 5 times this length of 3 times the force of 9 going down. And then we have 2 going to this other 9. So this is the two lengths. So we're going over 2. I tried to label these for you to make this moment calculation faster. Okay, so taking the moment around A, we get the reaction at Z, which is 5.25. From there, what we're going to do is just make sure everything in the Y direction adds together. So 9, 9, we've got 2 9s coming down, so that means 12.75 plus 5.25. That will add up to both of those 9 kilonewton forces coming down. Okay, so now that we have what's happening at the supports, you have a choice at this point to either start walking through the structure using a method of joints, or walking through using method of sections, or a combination of it. So I'm going to go ahead and start with method of joints, and we'll just start at one end and start working our way over. So let's look at joint A, and we've got our support 12.75 coming up. We have AB in compression coming down and AC in tension coming to the right. If I take these 3 vectors, put them into a triangle, so the support coming up, AB coming down, AC in tension coming over, the ratio of everything in this is going to follow our 3, 4, 5 ratio. So if I have one side of this, I know this side is 4/5 of the long side, or the long side is 5/4 of the Y side. So I can just walk around and use this 3, 4, 5 ratio to get everything else. So 12.75 here turns to 15.9 here, turns to 9.5625 here. So not really nice numbers coming out of this, but it is following the 3, 4, 5 ratios on this triangle. Okay, so that gets us AB, AC. The next thing we're going to do is walk up to joint B. So for B, the compression is now pushing up on this joint B. Whatever goes up has to come down. So we have BC right here is going to need to be pulling down in tension. And BD over here is again going to be in compression. And these 3 triangles, again, 3, 4, 5 triangles. So we have 15, and this is what we solved for before, was at 15. 12.75, and you'll see it's 12.75 that we had at the support. This is going to come rippling through the structure. So 12.75 coming down, 9.56 coming over. So I haven't written any equations for this new joint. It is the same numbers and the same ratios that we had before. So once you have this thing started, you'll see the same forces start to show up in multiple places. You see the same Y force being carried up and down for it. And it's looking at one of these larger systems. That is the hope, is that you'll see these patterns. And as soon as you get started, it'll start falling into place for you. So it'll get faster and faster as you go along. Okay, so now we have what BD is doing, what BC is doing, and we can keep moving to the next joint and the next joint. So here is C. So I've got 9 pulling to the left. I have 9 pushing to the left. So if I'm looking in the X direction, these two guys are going to add together. And now I have a larger tension going in CE, 19. Versus in the Y direction, I still have the 12 pulling up. So the 12 is coming down. So I still have the same stuff going on in the Y direction. So kind of interesting to start to see this X force getting larger and larger. And again, you can see I'm not actually writing equations here. I have a really good diagram that is big, that has X and Y forces labeled, and I'm just pulling numbers from my previous joint. So I'm grabbing the 1275, I'm grabbing the 9.56, I'm pulling those same numbers over, and this is the only calculation. I had to add everything in the X direction. So the compression is pushing it, the tension is pulling it. These two are combining forces so that now my tension is starting to get larger in the X direction. Okay, going on to the next joint D, and this is where things get interesting because I have the 9 kilonewton. This is where the external force was applied. So we should see a few things changing when we get to this external force. I've got my 12 and 9 coming over with my 15 that we've seen this multiple times now. We have my 9 coming over this way. And for the Y direction, I'm now going to have to remember what this external 9 is. So we have our 12.5 pushing up minus 9. So it still needs some help. So 375 plus 12, these two guys are going to combine forces to cancel out this 9. 9 plus 375 is 12. Okay, so now we're starting to get something different in the Y direction. And up here at the top, so we have kind of this compression ring around the edge of this thing. We had 9 going to the right, 9 going to the right, and now we see along the top, we are starting to increase what is happening along the rim of this thing. Some interesting things there. Okay, 375 coming down. Again, make big diagrams for this thing, and you'll start seeing the same numbers over and over again. So we've got 19 and 375. So we do now have a new triangle going on, and you can think of this bridge in 3 regions. So from A to where the first force is, from the first force to the second force, from the second force to the end. And you'll see a lot of the same numbers all the way till you get to that first force, and then you'll have kind of another chunk in the middle, and so there's a lot of patterns in here. Okay, so walking through this some more, we've got 375 coming up, which means I have to have that same 375 going down. That's only 2 things in the Y direction are this D and EF. In the X direction, a few more things going on. So 19 is pulling to the left. EF is pulling to the left. So we're going to combine forces here. 19 plus the 2 gives us a little bit larger force in the X direction. So you can see that we started small. We're getting larger and larger as we get to the center of the bridge. So what's happening on the edge, that tension along the base and the compression along the top, it keeps getting bigger and bigger and bigger as we're eating into this bridge. Okay, now that we have made it past that first external force, maybe we want to just pause here a little bit, check to make sure, did we really get all of these calculations and numbers right the whole time through? So what I'm going to do is just, let's chop this section off of here. So I'm drawing a line right through DF, FE, EG, and we're going to add up all of the forces and the moments on this section. So if I just pull my numbers that I had before, 19 is equal to 2.8 plus 21. So check everything in the x direction. And we can see, yep, that adds up to 0. How about the y direction for this section? So I've got the 12 going up, 9 coming down, and 375 coming down. So sure enough, 9 plus 375 is 12. So everything in the y direction adds to 0. For moments, and you can take the moment around any point you want, point E is a good one because I don't worry about EG, I don't worry about EF, I don't even worry about 9 because those are all coming straight through E. So E is just F versus FA, right? So I can check to make sure that the moments on this section add to 0 and all my numbers check out. So for walking through this bridge, use a combination method of joints, method of sections, and get through enough of this that you can watch those patterns start forming and the numbers start rippling through it. And I'm drawing big diagrams. I'm not being skimpy on the number of pieces of paper I'm using here. So I can have room to write in all of the numbers and all of the angles. I'm keeping that 3, 4, 5 triangle in front of me so I have the ratios of how this is going to play out for all of those slanted members. Hopefully this will, it's good practice to get through at least one of these larger structures to just see the patterns, and this is practice that'll get you so fast at adding vectors together, and all of mechanics is vectors. So forces, velocities, accelerations, moments, angular velocities, it's all vectors. And if you can deal with forces and adding forces together, you can keep track of any vector. Okay, I will leave it at that, and hopefully that was helpful.